Welcome to Educator.com. Today we're going to be going on to talk about solving systems of equations in 3 variables. In previous lessons, we talked about how to solve systems with 2 variables. So now we're going to go up to systems involving 3 variables. In order to solve these systems, you're actually going to use the same strategies you used for solving systems with 2 variables. Recall those techniques: substitution, elimination, and multiplication. This time, though, a solution is an ordered triple of values. So you'll end up with having 3 variables, for example, x, y, z. And the solution would be something like 5, 3, negative 2, where x is 5, y is 3, and z is negative 2. Now, just to work out an example to show you how to approach these using the same techniques that you already know. Looking at this system of equations, I have 3 equations and I have 3 total variables, and the idea is to work with the 3 equations so that you get one of the variables to drop out. Once you get one of the variables to drop out, you'll be left with a system of 2 equations with 2 variables, and you already know how to work with that. So the technique would be to first just consider 2 of the equations together. So I'm going to call these equations 1, 2, and 3 so I can keep track of them. I'm going to first consider equations 1 and 2. And when I look at these, I see that I have z, the 2 z's have opposite coefficients. And you'll recall that elimination works really well in that situation. So I'm going to take 2x plus 3y minus z equals 5. So that's equation 1. And equation 2, 3x minus 2y plus z equals 4. And I'm going to add those. This will give me 5x, and then 3y minus 2y is going to give me y. The z's drop out. 5 and 4 is 9. So now I have a new equation. And I'll just mark this out so I can keep track of it. So once you've gotten a variable to drop out, work with 2 different equations to get the same variable to drop out. So I got z to drop out, and what I want to do is work with 2 different equations. I worked with 1 and 2. So I could work with 1 and 3, or I could work with 2 and 3. And I'm actually going to work with 2 and 3. And I want to get z to drop out. So equations 2 and 3, looking at this, how am I going to get z to drop out? Well, in order to do that, I could use elimination, but I'm first going to have to multiply this second equation by 2. So this is equation 2, and it is 3x minus 2y plus z equals 4. And I'm going to multiply that by 2 to give me 6x minus 4y plus 2z equals 8. Now I'm going to take equation 3. So this is equation 2, and I'm going to take equation 3. I want to make sure that I'm working with 2 different equations. So I have 1 and 2 and 2 and 3. Or I could have done 1 and 3. Either way. Negative 4x plus y plus 2z equals 3. My goal is to get the z's to drop out. In order to do that, I'm going to have to subtract. I need to subtract 3 from 2. So I want to be very careful with my signs here. So I'm going to change this to adding the opposite. So this is going to give me 6x plus 4x, which is 10x. Negative 4y and negative y is negative 5y. 2z and negative 2z drops out. 8 minus 3 is 5. Okay, at this point, what I'm left with is a system of two equations with two unknowns. Once you get that far, you proceed using the techniques that we learned previously. Again, substitution, elimination, multiplication. But since you're only working with two equations with two unknowns, you're on familiar territory, and you can solve for one of the variables and then find that value, substitute in for the other variable, find that value, and then you can go back and find z. And we're going to work more examples on this, but the basic technique is to work with two equations to eliminate a variable using either elimination or substitution, then work with two other equations to eliminate that same variable, resulting in two equations with two variables, allowing you to solve for one variable, then the other, and then the third. Just as in systems with two variables, a system with three variables may have one solution, no solutions, or an infinite number of solutions. So recall the solution set here, if I had three variables, x, y, and z, would be a value for x, such as 2, a value for y, such as -4, and a value for z, such as 1. That would satisfy all three equations. The other possibility is that there may be no solutions. Recall from working with systems of equations with two variables, you know that you're in this situation when you're using elimination, you're using substitution, you're going along, and then you see variables start to drop out. And you end up with an equation where you have a constant equaling another constant, which is never true. So if you start seeing variables drop out and you end up with something such as 4 equals 7, which is never true, this tells you that there's no solution to the system of equations. There can be an infinite number of solutions. When you're working with your equations, you're eliminating, you're substituting, you're using your techniques, you're being careful, you're doing everything right, and then you see variables drop out and you get a constant equals a constant, like 2 equals 2. Well, that is always, so example 2 equals 2, that is always true. And this means that that system of equations has an infinite number of solutions. So typically you'll get one solution, a value for x, y, and z that is the set of values that makes the equations true, that satisfies the equations. You may end up, though, with no solutions. There's no solutions to this equation, or an infinite number of solutions for the system of equations. Okay, in the first example, we're given a system of three equations with three variables. So again, I'm going to work with two of the equations. I'll number them, 1, 2, and 3, and I will work with two of them and then a different two. So first, I'm going to look at the second two equations, and they're very easy to work with because I have opposite coefficients. I could also use substitution because I have coefficients of 1, but I'm just going to use elimination. So first I'm going to work with 2 and 3. Y minus z equals 2. X, move that so it doesn't create confusion. X plus 2y plus z equals 2. Okay. Here I end up with x. All I'm doing is adding these together. So I'm adding these together using elimination. X plus 3y, z's drop out. 2 plus 2 is 4. Okay, so I eliminated z from this first set of equations. Now I need to work with a different set of equations. And there's actually multiple different ways to approach this. And I'm going to work with 1 and 2. I already worked with 2 and 3. So I eliminated z, and I want to actually, let me see, 2 and 3. So I eliminated z. So actually, I've already got this does not have z in it. So I don't even need to proceed That way I've already got two equations with two unknowns. This is a particularly easy situation compared with when all three have three variables. Okay, so I look up here and I've got my new equation. I can call that equation 4. And then I've got equation 1, and these just have x and y. So I'm just going to proceed like I usually do with two equations with two unknowns. Let me rewrite these right here. 2x plus y equals 3, and this is x plus 3y equals 4. I can use substitution. That would be fine because I have a coefficient of 1. So here I'm going to solve for y. And this will give me y equals negative 2x plus 3. And then I'm going to substitute into this equation. So I have x, and I'm going to substitute for y, plus 3 times negative 2x plus 3 equals 4. Working this out, x, 3 times negative 2x is negative 6x. 3 times 3, that's 9, equals 4. Here, now I just have an equation with a single variable, so I can solve that. First, combining like terms, x minus 6x is negative 5x plus 9 equals 4. Subtracting 9 from both sides, negative 5x equals negative 5, x equals 1. Okay, so the first thing I wanted to do is just get rid of one of the variables. So I'm just working with two variables. And I did that by just adding these two, the second and third equations. The z dropped out. I was lucky because the first equation already didn't have a z. So I had two equations with two unknowns, and then I just used those two. I solved by substitution, and I came up with x equals 1. Since I know that x equals 1, I can go ahead and substitute this in to this equation to find y. So looking at equation 1, 2x plus y equals 3. I know that x equals 1, so that's 2 times 1 plus y equals 3, or 2 plus y equals 3. Subtracting 2 from both sides, I get y equals 1. So now I have x and I have y. I need to find z. Well, this will easily tell me what z is. So that's y minus z equals 2, and I know y. Y equals 1. So 1 minus z equals 2. Negative z equals 1. Therefore, z equals negative 1. So the solution to this set of equations is that x equals 1, y equals 1, z equals negative 1. The hardest step was just getting rid of that third unknown, for third variable. So I did that by adding these two together. Then working with two equations with two variables, I was able to solve for x. Once I'm there, all I have to do is start substituting. Here, I substituted x into the first equation and solved for y. Once I got y, then I was able to substitute y into the second equation to solve for z. So 1, 1, negative 1 is the solution for this system of equations with three variables. Okay, example 2. Again, my goal is going to be to get a variable to drop out. So I'm just left with two variables. Looking at this first and second equation, considering these together, y and negative y, if I add those together, the y's will drop out because they have opposite coefficients, 1 and negative 1. So I'm going to start out by adding the first two equations. This is 1 and 2. X plus y plus z equals 2. And then I'm going to add x minus y plus 2z equals negative 1. And I'm going to come up with a new equation. This is 2x, y's drop out. Z plus 2z is 3z, 2 minus 1 is 1. Okay, I have this. And I worked with these first two. I now need to work with two different equations to get the same variable to drop out. This time, I'm going to pick equations 1 and 3, and I want y to drop out. So I have equation 1 and 3. That's x plus y plus z equals 2. And that's x minus y, or actually equation 3. That is 2x plus y plus 2z equals 2. Now, I need to subtract in order to get the y to drop out. To keep everything straight as far as my signs go, I'm going to keep the first equation the same. But for the second one, I'm going to change it to adding the opposite. Add negative 2x, negative y, negative 2z, and negative 2. Okay. X minus 2x is negative x. Y's drop out, which is just what I wanted. Z minus 2z is negative z. 2 minus 2 is 0. Now I have two equations, two variables. Rewriting these two up here to see what I have to work with. 2x plus 3z equals 1. Now I just use my usual methods of solving system of equations with two variables. Since I have coefficients here of negative 1, it's pretty easy to use substitution. So I'm going to solve for x in this second equation, and then substitute that value up in the first equation. So I have negative x minus z equals 0, which would give me negative x equals z, or x equals negative z. So I'm going to take this negative z and substitute it in right here. Okay, that gives me 2x plus 3z equals 1, and let x equal negative z. So 2 times negative z plus 3z equals 1. That's negative 2z plus 3z equals 1. Combine these two like terms to get z equals 1. Now I've got my first value. Okay, so I know that z equals 1, so I'm on my way. And I look up here and I see, well, I know that x equals negative z. So that makes it very easy to solve for x. If x equals negative z and z equals 1, then x equals negative 1. So now I have x equals negative 1, z equals 1. I'm just missing y. Well, look at that first equation, and it tells me that x plus y plus z equals 2. X is 1. The x is negative 1. I don't know y. And I know that z is 1. These two cancel, and that gives me y equals 2. So negative 1 plus 1 is 0, so I end up with y equals 2. So putting all this together up here as my solution, I end up with x equals negative 1, y equals 2, and z equals 1. So that was a lot of steps, so it's really important to keep track of what you're working with, especially in the beginning, that you work with two equations. I worked with 1 and 2 to get a variable to drop out. I added those, and the y's dropped out. Then I want to work with either 1 and 3 or 2 and 3, two different equations to get the y to drop out. I chose 1 and 3, and I saw that I could get the y to drop out of 1 and 3 if I just subtracted 3 from 1. That's what I did right here. At that point, and I clearly mark out what I ended up with, which is two equations with two variables. Rewrote those up here, and I decided I was going to use substitution. I solved for x in this second equation, x equals negative z, substituted that in right here, so into the first equation. That allowed me to have one equation with one variable, z, and I determined that z equals 1. From there, it was much easier because I saw that x equals negative z, and I knew z, so x equals negative 1. I had x, I had z, and I had three equations that I could have used, but I picked the easiest one to substitute in x and z and solve for y to get my set of solutions. Again, a set of 3 equations with 3 variables that I need to approach systematically. And my first goal is to eliminate a variable, is to eliminate the same variable. So I'm working with 2 equations with 2 variables. And I see several possibilities. You could approach it differently, and you'll come up with the same answer as long as you follow the rules and the steps. I'm seeing that negative y and y are opposite in terms of coefficients, negative 1 and 1. So I'm going to add those 2. I'm going to add 1 and 3. That's going to give me 5x. The y's drop out. So 5x minus z. 1 minus 3 is negative 2. I just mark that so I can keep track of it because I'm going to need to use it in a minute once I generate another equation in which y has been eliminated. Okay, I worked with the first and the third. Now I need to work with 2 different equations, and I'm going to work with the first and the second. And I want to eliminate y. In order to eliminate y, I need to multiply the first equation by 2. So I'll do that up here. This is going to give me 4x minus 2y plus 2z equals 2. So that is this first equation. Now I'm going to add it to the second equation. Plus x plus 2y minus z equals 0. Adding these together, I'm going to get 5x, y's drop out, 2z minus z is z, 2 and 0 is 2. Okay, I first worked with the first and the third, and then I worked with the first and the second to get the y's to drop out. So now I have 2 equations and 2 variables, x and z. So put these together. 5x minus z equals negative 2, so I can see what's going on with them. 5x plus z equals 2. Well, I can see that if I add these, z will drop out. And I'm just back to my usual 2 equations with 2 variables, usual techniques. 5x and 5x is 10x. Z's drop out. Negative 2 and 2 is 0. Divide both sides by 10 gives me x equals 0. So I have my first value, which makes things much easier. Since I know that x equals 0, I can substitute into either of these to solve for z. So 5x minus z equals negative 2. So 5 times 0 minus z equals negative 2. 0 minus z equals negative 2. Negative z equals negative 2. Divide both sides by negative 1 to get z equals 2. I have my second value. Okay, so I know x, I know z, I just need y. I'm going to solve for y. I could use any of these. I'm going to pick the top one. So solve for y. Knowing that x equals 0 and z equals 2. Okay, that's 0 minus y plus 2 equals 1, which gives me negative y plus 2 equals 1. Subtract 2 from both sides to get negative y. So if I say 1 minus 2, that's going to give me negative 1. Multiply all of that by negative 1 to give me y equals 1. Okay, so the solutions here is x equals 0, y equals 1, and z equals 2. And I approach that by seeing that y and negative, I could add 1 and 3 because of negative y, and those would drop out. I could have added the first 2 and had the z drop out and had that be my variable to eliminate. I happened to choose y. Added those together, got this equation. Then I worked with the first and the second equation, a little more complicated, because to get opposite coefficients, I had to multiply the first equation by 2. I did that to generate this equation, which I added to the second. This is the resulting equation. I then had two equations with two variables. Looked at those two and saw I had opposite coefficients with z. So when I added them together, z dropped out, and I could solve for x. Once I determined that x is 0, I substituted 0 into this top equation for x to solve for z and determine that z equals 2. At that point, I just needed to solve for y. So I took this equation and substituted my value for x, my value for z, and determined that y equals 1. So again, you're using the same techniques that we used previously, only you're working with more equations and there's more to keep track of. Okay, in this system of equations, 3 equations with 3 unknown, a little bit more complicated. I do have one equation that has a coefficient of 1, but the rest of them have larger coefficients. So I'm going to work with the first and second equations, and what I want to do is eliminate the z. So in order to do that, I'm going to need to multiply this first equation by 2. So I want to work with the first and the second equations. I want to get the z to drop out, but I need to multiply this by 2 first. So let me do that right over here. So that's going to give me 6x minus 4y plus 2z equals 8. So I'm going to rewrite that right here. 6x minus 4y plus 2z equals 8, and that came from that first equation multiplied by 2, and I'm going to add it to the second equation. So plus negative 6x plus 4y minus 2z equals 2. Now, you might have already seen what happened. I was really just focusing on, okay, I want to get the z's to be the same so that they would cancel out. But what happened is, or z's to be opposite coefficients so they would cancel out. But what happened is everything ended up with opposite coefficients. 6 and negative 6, negative 4 and 4, 2 and negative 2. Okay. So I've got 6x minus 6x, that's 0. Negative 4y and 4y, 0. 2z and negative 2z, 0. 8 and 2, 10. 0 equals 10. Well, we know 0 does not equal 10, so this is not true. It's never true that 0 equals 10. So there's no solution to this set of equations. I could have had a situation where I got a solution. I could have also had a situation where maybe I got 10 equals 10 with a different set of equations, with a different system of equations. If I had come up with something like 0 equals 0, that's always true, or 10 equals 10, then I would have had an infinite number of solutions. But instead what happened is my variables drop out. I got c equals d, which is saying that I have a constant that's equal to another constant, which is never true, so there is no solution. So this one turned out to actually be less work than the others, but when this happens, you just want to be really careful that you were doing everything correctly, you didn't make a mistake, but actually it can end up that there simply is no solution to the system of equations. So that concludes this lesson on educator.com on solving systems of equations with 3 variables, and I will see you next lesson.